We're continuing section 2.6, which is focusing on the angle proofs. And today we're going to learn a couple new things that are going to help us out with a lot of these angle proofs. Give us some more reasons to postulate 12, but we'll never refer to it as postulate 12 because that's what our textbook refers to it as or has numbered it as. We're going to call this the linear pair postulate, and we'll use LPP as our acronym to remember that. So LPP is the linear pair postulate. And do we remember talking about linear pairs already before? Because we've seen that vocabulary term.
Yeah, we saw this in chapter 1, and we kind of already explored a little bit, but all we learned about linear pairs was the definition, and then we kind of elaborated on that. And we know a linear pair, by definition, is where there are adjacent angles, so they're a pair of adjacent angles that form a line, basically.
Yeah, two sets of opposite, not in common side or opposite rays. So form a line. I like that. Okay, so before we discovered some relationships, but we didn't necessarily have anything that we could use to just state that we knew that those linear pair, the angles would be supplementary.
Yeah.
The linear pair postulate is what allows us to do that. So it says that if two angles form a linear pair, then they are supplementary. We found that before. We discovered that when we were looking at the relationships there, but now we've got a postulate that we can use as a reason and a proof. So now if we know that we've got a linear pair, which this is one of the very few things that we will allow you to say based off of the picture, we know it's a linear pair.
Okay.
So if you know that you've got two angles that together form a straight line, then we know that they're a linear pair.
So we could just right from this picture say angle 1 and angle 2 are supplementary, right?
Perfect.
And it'd be based off of the linear pair postulate. We can't say that they're supplementary because of the definition of a linear pair, because based on the definition, it talks about adjacent angles, opposite ray type stuff.
Exactly. So this is it's a very nice shortcut for us. When you see a linear pair just from a picture, there's now something we can state just from a picture, and that doesn't happen very often. So this is one of those very few things we can do.
And get comfortable with this this postulate because we're going to use it a lot.
LPP.
The other, kind of going off of what Ms. Hogarby said, remember back to chapter 1, we talked about linear pairs, but the other pairs of angles that we talked about were vertical angles. Right. And we actually explored this idea as well back in that chapter. However, we learned about that definition again. But this is a theorem. Okay, again, postulates are unproven statements that we accept to be true. Theorems actually can be proven. Okay. So this is called the vertical angles theorem, and we do an acronym for it as well because we use it a lot.
Both of these we will use a lot.
VAT. So vertical angles theorem, VAT. So vertical angles theorem basically says, it's short and sweet, vertical angles are congruent.
And if you forget vertical angle theorem, you can always say vertical angles congruent.
Exactly.
Now, don't just say vertical angles.
Yes.
Because that to me would maybe think, do you know is it the definition or what are you saying about them?
Yes.
So either vertical angle theorem or vertical angles are congruent.
So this is another one, like the linear pair postulate, you can state this from the picture. So when you look at the picture, can you name me a pair of vertical angles in this picture?
Okay, so angle 1 and angle 3 are vertical angles.
So based on the vertical angle theorem, we can then conclude angle 1
is congruent to angle 3.
So this again because of the vertical angle theorem. And we can also say angle
2 is congruent to angle 4. So this is another one that we can just based off of the picture, when you've got two intersecting lines, we know those vertical angles are congruent.
Exactly. And the definition of vertical angles only says what they are. Vertical angles are a pair of angles that are created by two intersecting lines, two opposite sets of, or two pairs of opposite rays. Doesn't ever say anything about them being congruent.
Right.